Good day everyone. Welcome to CS 410 project presentation for language and compiler design. This presentation is based on the language named TABL. General outline. We will introduce what the language is and then split the presentation into two portions. Number 1, the grammar of the language, and number 2, the compiler for language. Introduction. So what is table? Table is a language intended to create, manipulate and store tables. Table is not meant to function as a heavy database. It is just a language that works with a single table at a time. It is designed for programmers, which is the reason for its syntaxes to be like C++. It will create and store tables in its own format .tbl. Table also has three basic data types: integer, float, and string. Having these limited data types goes hand in hand with our vision of creating a tool that is not overly complex to learn. Since we want to create this for programming students and individuals that want to create and store data related to schedules and more, these primitive data types should suffice all purposes. A thing to remember is that table will export its table in .tbl format. It can similarly import its table in .tbl format, but the code should be written in .tblc formats.
The code of the table has four components: start component, import or make component, expression component, and end component. Three of them are mandatory, that is start component, import or make component, and end component. We have designed in such a way that the code is invalid if we don't include them, and one is optional, that is expression component. Let's begin with the first component, that is start. The first line of the table has to start with the start component. Likewise, we mention the header in C or C++ or in any other programming languages. We can see the syntax of the start expression down here. We can only give some white spaces or put some comments before the table.start. Anything other than would be grammatically incorrect and compiler will throw an error. The import or make component appears just after the start component. I would say this will be the second line of the code. The main purpose of using import or make component is to give options to the user whether to import a table which is already created and saved in particular file which they would like to work on, or to make a new table from the scratch. From this statement, we can initialize the symbol structure. We can see the syntax of the import statement as well as make statement below. The third component is expression component, and it is the main body of our program. It can be either empty or it has some 8 operations. When it is empty, our compiler will not do anything but the code is acceptable. When it is not empty, it has some operations to do. Let's start with insert operation. To create a table, we need to insert some values into rows and columns. This expression is used to insert some values into rows and columns to give structure to the table. The second one is print expression. This expression is used to print the values of present row or column to outstream. So if we want to see some values of a row or a column, we can use print expression. It will print the value of required row or column. In case if we cannot do that, we should print it out to log.txt in currently working directory, and we can check printed value there. And the third expression is delete expression. This expression is used to delete a row or column by giving the table name. We can delete only one at a time. And the fourth expression is sort expression. We can sort the table by giving the certain value. Suppose we have student table, and if we want to get only the grades of the student in ascending order, we can simply do it by sorting the table and giving the column name as grades. It will sort the grades of the student in ascending order. Filter expression. We can filter out the required column or row when the user gives the file name with .tbl extension. So if a user wants to get student ID from the student table, he or she will use student ID as a value to filter out by giving test.tbl as a file name, and they will get only student ID in the file test.tbl. The sixth one is movement expression. This is used for some arithmetic operations on rows and columns such as increment, decrement, addition, and subtraction. For instance, we can use this to add all the grades of the student in the student table, or we can use that to increment or decrement the rows or columns by giving the count. The seventh one is edit expression. We can edit a value in a current row by using edit expression. Suppose if we want to make some changes in a row, we can easily replace it with new value by using edit expression. And the last expression is export expression. Once the operations are done with the table, we can export the output being the .tbl extension, so we can see the results of the table in there. Now I'm going to talk about the last component, that is end component. End component indicates the end of our table program. If we don't mention the end statement in the code, and if we try to run the code, every lines of the code will be treated as invalid and compiler will throw an error. Here we have the syntax of the end statement.
Section 2. Compiler of table. The table compiler is split internally into two sections. Section 1 is the lexer and parser implementation using ANTLR, which will produce a parse tree, and section 2 is the compiler implementation which uses the parse tree produced from section 1 as its input. It is better to show how the compiler works with the use of some test cases. This will be done on the Hercules command line window, and that is why we will migrate from this presentation here. The compiler process is split into two major parts. Number one, lexing and parsing using the ANTLR and table.g4 file, and number two, using the parse tree from ANTLR as input in our compiler. The grammar, which was explained by Sushita earlier, can be found in table.g4 file. We create parse trees referring to this grammar with the help of ANTLR. Once we have a parse tree, it is used as input in our compiler. This is our second process. We split the parse tree into meaningful tokens to create a symbol table structure. We then try to convert the .tblc code into target code, which for our case is .cpv. If there are any errors found while converting, we store it in our error structure. Once the whole code has been analyzed, we can convert it into an executable named table. Table executable upon running will either output the error structure or successfully do what the table code told it to do so. You can find the whole code for compiler and table.g4 in our report. Now, to better visualize what I just tried to explain, let us look at some pass and fail cases in the Hercules command line window. Welcome back, guys. So this is the Hercules command line window, and I am gonna navigate to my tests directory. Okay, so we have two folders, fail and pass. I'm gonna show you three test cases for each, so I don't take up too much of your time. So now let us go to the pass directory, cd pass. Okay, so we do have the table executable right here, but let us actually clean and then build it again. Okay, so we can just show that we have a make file for our compiler. Now let us execute the table. I go to test one. Let us analyze the code now. So for code one, I have table.start, then I make the table. I insert column, which is S number, right here. Then I insert name with default as minus, I mean the dash sign. Then I insert another column with default marks as 0.00. Then I insert a row, which means now I should have two rows, actually three if we count the column naming row. Okay, so now I do row minus minus, which means I point back to row number one. And now I'm editing that row with the name as Sushita. As you know, default name was minus. So now it should be Sushita, which is true. Then we print the table. So yeah, we can see we have three rows. Default name here was Sushita in this, sorry, minus, but we changed it to Sushita, which is good. This was an auto incrementing S number row, so this is good. So we haven't given any name or marks here yet, so this is also good. And then we move back to row number two, and then we end the code. Okay, so test one is good. Now let us do test two. Test two. Okay, so we have this sort of output here. Okay, let us go to the code file. We make the table, then we insert three columns. One is S number, which is auto. The other is name, default is minus, and then the third is um, float type with name marks. Default is 100. Now we edit the current row and we name it to Ritwik and marks are set to 90.90, which is true, and then we print the row, right? So currently we were at row number one, marks are this, yep, this is true. Then we insert another row. We edit that row with these values, so Shita and 89.99, which is also true because we print the row here. Then we export this whole table as test table. Okay, so let's see if we have test table.tbl. Oh, we do. Let's open it. Okay, so we are doing the test 3 for pass and we are in the directory. So we will now /table. I'm sorry. Okay, so we get an output like this. Let us check our code file. So we import the test table from test2 as test table 3. Then we print the whole table like this. Then we insert a column student ID with default value 101. Then we decrement the row and we edit the row that we are pointing to right now. And we change the student ID to this value here. Then we filter the data for the column name to filter test.tbl. Then we sort the table by student ID and then we export the table as test table 3. So now we will check if we have a filter table and test table 3. Let us just refresh. Yep, we do. Let's open test table 3. Okay, so we have everything. We have student ID and we have it sorted. So 101 is less than this. So in ascending order, this is sorted, which is good. And now we are checking the filter test. We filtered out the column with names, which is true. So we are good with the pass test 3. Now let us do the test 5. So we can go to test 5 directory and then execute the table. Okay, so we get something like this. Let us check our code. So we import the test table, then we print the table, which is what we did right here, as you can see. Then we insert column for the table, integer type, student ID, and it is auto. Then we print the row for the table. Since we imported the table, we will be pointing at the last row. That means at this row, and we are printing that row out. And then we have also added the student ID column with auto increment. So at row 2, it would be 2. So this is the correct output. Then we do row minus 1, and then we edit the current row with student ID this, and then we print the whole table. Since we did row minus 1, we were editing row 1, and then we set the student ID this, and the table as this. Now we are inserting a row in between row 1 and row 2, and then we are changing the student ID and test and name to test edit 5 with marks 88.88. So this is what it is. And one thing to remember is that when you add rows in between two rows, when you add a row in between two rows, then the row that you are adding will take on by default the values of the row after it. So here this number is actually 2 and it stays 2 here. Okay, so now we export this table as test table 5. We delete the column, current column. That means we will delete student ID column and then we print it again. So that should be this, which is correct. Now let us check the test table 5.tvl. It should have a table with the student ID as well. Yes, this is correct. Okay, so we have done the past tests. Now let us look at the tests for fail cases. So I will open the fail directory now. And then let's do test 1. Okay, so it shows antler parse error. We expect a make expression or import expression token here. Let us go to the test1 directory and check our code. What did we write? Oh, it seems like we haven't written the import or make statement. That means that our compiler doesn't know what table to work with, and that is not acceptable, which is why we throw a make expression or import expression error here. Now let us do test 3. Okay, we get two errors. We expect a name value token after data type specification, and we are going out of bounds with some subtraction operation. So let's see. Okay, as you can see, we need a name value after specifying the type. So this should be name, and this is its value. But this is incorrect, which is why we get the error. And we are also going back 5 columns. But to do that, we should have actually 5 columns in the table, which we don't. So this should also fail, which is true. Okay, now let us go to test 6, or rather test 5 actually. Okay, so we get an error. There should be 2 token after filter statement, and there should be a semicolon and at edit, right? So let us open the code file. We import the test table. We do have the test table file, so this statement works. Okay, so as we know, the syntax for filter is filter data for row to some table name, right? There is no need for this thing here. It is garbage. So it should throw an error, which is true, as we can see here. And it also says that we are missing a semicolon parsing it edit, which is true. We are not having a semicolon here and here for that matter. Okay. So with these 3 illustrations on the failed test cases, I hope the compilation process is much more clearer to you for using table. I will now migrate back to the PowerPoint presentation. This marks the end of the presentation. Thank you for watching. All questions, criticisms, and suggestions are welcome. Hope you understood something new.